Preparing for a Java developer at Kyndryl interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Which Java features introduced in recent LTS releases have you used in enterprise applications? Java is platform independent because source compiles to bytecode executed by the JVM. In enterprise projects, I favor LTS releases, records for immutable data carriers, sealed classes for controlled hierarchies, and pattern matching where supported. I evaluate compatibility with existing application servers and libraries before upgrading. New features should improve readability and maintenance, not merely add novelty. I also validate performance, deployment behavior, and rollback plans before introducing them into production services. While answering, cover records, sealed classes, pattern matching, switch expressions, text blocks, virtual threads, LTS compatibility, migration risks, and how features improve maintainability without compromising production stability. Question 2. How do equals and hashCode work together, and what problems occur when they are implemented incorrectly? The equals and hashCode contract ensures objects considered equal produce the same hashCode. I override both together, using stable fields that represent business identity. If a mutable key changes after insertion into a HashMap, lookup can fail because the object belongs to a different bucket. I use objects, equals and objects, hash or records when their generated value semantics fit. I also test reflexivity, symmetry, transitivity, consistency, and null handling. Make sure to cover the equality contract, hashCode consistency, mutable fields, HashMap and HashSet behavior, identity versus value equality, records, and practical testing of custom domain objects. Question 3. When would you use checked exceptions, unchecked exceptions, or custom exceptions in a Java service? I use checked exceptions when callers can reasonably recover and must acknowledge the condition, although many modern service layers prefer unchecked exceptions for cleaner APIs. Unchecked exceptions suit validation failures, illegal state, and programming defects. I create custom exceptions for meaningful domain or integration errors, preserving the cause. At boundaries, I translate exceptions into stable HTTP responses or messaging outcomes, log them once with context, and never catch exception merely to hide failures. In your answer, distinguish recoverable conditions from programming failures, explain exception propagation, custom domain exceptions, meaningful messages, logging boundaries, API mapping, and avoiding swallowed or overly broad exceptions. Question 4. How would you choose between ArrayList, LinkedList, HashSet, TreeSet, and HashMap? I choose collections based on access patterns rather than habit. ArrayList is my default for indexed reads and iteration. LinkedList is uncommon unless frequent iterator-based insertion matters. HashSet provides uniqueness with average constant time lookup, while TreeSet maintains sorted order at logarithmic cost. HashMap stores key-value associations efficiently, and TreeMap provides ordering. I also consider memory, null behavior, iteration guarantees, and whether a concurrent collection is actually required. Be sure to mention access patterns, insertion and lookup complexity, ordering, uniqueness, sorting, memory overhead, null behavior, concurrency considerations, and selecting the simplest collection matching requirements. Question 5. Explain Java streams and describe a situation where you would avoid using them. Streams represent a pipeline of operations over data. Intermediate operations are lazy, and a terminal operation triggers execution. I use them for readable filtering, mapping, grouping, and aggregation, such as converting orders into totals by customer. I avoid side effects inside lambdas and rarely use parallel streams without measurement. For complex branching, checked exceptions, or performance-critical tight loops, an explicit loop can be clearer, easier to debug, and safer. Focus on lazy evaluation, intermediate and terminal operations, stateless transformations, collectors, side effects, parallel streams, readability, debugging, and choosing loops when control flow or performance is clearer. Question 6. How does the JVM manage memory, and how would you investigate a memory leak? Each thread has stack frames, while objects generally live on the heap and are reclaimed when unreachable from garbage collection routes. To investigate suspected leaks, I monitor heap usage after collections, capture heap dumps, and inspect dominator trees with a profiler. Common causes include unbounded caches, static collections, listeners, thread locals, and unclosed resources. I reproduce the growth, identify retaining references, fix ownership, and verify behavior under realistic load. Cover stack and heap areas, garbage collection routes, generations, retained objects, heap dumps, allocation profiling, monitoring, common leak sources, and distinguishing leaks from legitimate high memory usage. Question 7. How does dependency injection in Spring improve the design of a Java application? Dependency injection moves object construction and wiring away from business classes. I prefer constructor injection because required dependencies are explicit, objects can be immutable, and unit tests can provide mocks directly. Spring manages bean lifecycles, configuration, and cross-cutting concerns, while interfaces keep business code replaceable. I avoid field injection and excessive component scanning. I also watch for circular dependencies, unclear scopes, and placing important business decisions inside configuration classes. Mention inversion of control, constructor injection, bean scopes, configuration, interfaces, testability, lifecycle management, circular dependencies, and avoiding excessive framework coupling in core business logic. Question 8. How would you design a production-ready REST API using Spring Boot? I begin with resources and clear HTTP semantics. Get reads, post creates, put replaces, and delete removes. I validate request DTOs, return consistent error bodies, and use appropriate status codes. Pagination, filtering, ID impotency keys, and correlation IDs matter for enterprise clients. I separate controllers, services, and persistence models, secure endpoints with OAuth 2 or an approved identity provider, document them with OpenAPI, and version changes carefully to preserve compatibility. In your answer, include resource modeling, HTTP semantics, validation, status codes, pagination, error contracts, ID impotency, versioning, authentication, observability, documentation, and backward compatibility. Question 9. What are the main challenges of moving a monolithic Java application toward microservices? The hardest part is discovering stable business boundaries, not creating deployable jars. I identify bounded contexts, assign data ownership, and extract a low-risk capability using a strangler approach. Services communicate through well-defined APIs or events, with timeouts, retries, and correlation IDs. I avoid distributed transactions by using local transactions and compensating workflows. Before splitting, I ensure automated delivery, monitoring, operational ownership, and a clear reason that independent scaling or release is valuable. Discuss bounded contexts, service boundaries, data ownership, distributed transactions, network failures, observability, deployment maturity, strangler migration, team ownership, and avoiding microservices when decomposition adds unnecessary complexity. Question 10. How would you make a Java microservice resilient when a downstream dependency becomes slow or unavailable? I set explicit connection and request timeouts first, because an unbounded wait consumes threads. Retries are limited, use exponential backoff with jitter, and apply only to transient, idempotent operations. A circuit breaker stops repeated calls when failure thresholds are reached, while bulkheads isolate resources between dependencies. Depending on the business case, I return cached data, queue work, or a clear degraded response. Metrics and traces verify that resilience improves user impact. Be sure to cover timeouts, bounded retries, exponential backoff, circuit breakers, bulkheads, fallbacks, ID impotency, rate limiting, health checks, metrics, and preventing retry storms or cascading failures. Question 11. How would you use Kafka or another message broker in an enterprise Java solution? I use a broker when asynchronous processing, decoupling, or durable event distribution is more valuable than an immediate response. I design events around business facts, choose keys deliberately for partition ordering, and place consumers in groups for scalable work sharing. Because duplicates can occur, consumers must be idempotent, commonly using an event identifier or business key. I add retry and dead letter handling, compatible schemas, lag monitoring, and clear replay procedures. Cover event design, producers, consumers, partitions, consumer groups, ordering, delivery semantics, retries, dead letter queues, schema evolution, idempotent processing, and monitoring lag. Question 12. Explain transaction management in Spring and describe how you would handle a failure across multiple data operations. I place a transaction boundary around one cohesive business operation, usually at the service layer. Spring can roll back unchecked exceptions by default, while checked exception behavior should be configured deliberately. I select isolation based on consistency needs and use optimistic locking for competing updates. A database transaction cannot safely span independent services, so I use an outbox and event-driven compensation or a saga. I keep transactions short and never perform slow remote calls inside them. Mention transaction boundaries, propagation, isolation, rollback rules, read-only transactions, database constraints, optimistic locking, distributed transaction limitations, and compensating actions for cross-service workflows. Question 13. What testing strategy would you apply to a Spring-based Java application? I build a testing pyramid, fast unit tests for business rules, focused Spring slice tests for web or persistence behavior, and fewer full integration tests for real boundaries. Test containers can provide realistic databases or brokers without relying on shared environments. I mock external systems at unit level but use contractor integration tests to verify actual interfaces. Tests should assert behavior, remain deterministic, run in C, and expose defects rather than inflate coverage metrics. Discuss the testing pyramid, unit tests, slice tests, integration tests, contract tests, test containers, mocking boundaries, test data, C execution, reliability, and balancing coverage with meaningful behavior verification. Question 14. How would you secure a Java REST service against common application vulnerabilities? I authenticate requests with a standard identity provider and authorize each operation using roles or, preferably, resource-level permissions. I validate inputs, use parameterized queries, encode untrusted output, enforce TLS, and keep secrets outside source control. Spring Security helps establish consistent filters and policies, but configuration still needs review. I patch dependencies, add security tests, rate limit sensitive endpoints, record security relevant events, and avoid logging tokens or personal data. Include authentication, authorization, least privilege, input validation, output encoding, TLS, secret management, SQL injection prevention, secure headers, dependency scanning, audit logging, and threat modeling. Question 15. How would you modernize a legacy Java application while minimizing operational risk? I first map dependencies, critical workflows, runtime behavior, and operational pain points. Characterization tests protect existing behavior before refactoring. Then I create seams around a bounded capability, expose a stable interface, and migrate incrementally through a strangler pattern. Feature flags, parallel validation, dashboards, and rollback plans reduce risk. I modernize the highest value paths first, while preserving data integrity and documenting decisions so future teams can continue the transformation. Focus on inventory, characterization tests, dependency analysis, incremental migration, strangler pattern, API seams, observability, feature flags, rollback, data synchronization, and measurable business outcomes. Question 16. How would you design a scalable Java service for a high-volume enterprise workload? I start with traffic, latency, availability, payload, and growth estimates rather than choosing technologies immediately. I keep service instances stateless behind a load balancer, cache-safe repeated reads, index database access, and move slow work to asynchronous processing. Backpressure protects the system when demand exceeds capacity. I design for horizontal scaling, isolate dependencies, and define SLOs. Load tests, profiling, and production metrics determine whether optimization actually improved the bottleneck. Mention capacity estimates, stateless instances, load balancing, caching, database indexing, read replicas, asynchronous work, backpressure, horizontal scaling, failure isolation, observability, and performance testing. Question 17. A Java service is timing out in production. How would you diagnose and resolve it? I first confirm scope, affected endpoints, error rates, and whether latency is internal or downstream. Dashboards and traces reveal slow spans. Thread dumps expose blocked threads, while database plans and pool metrics identify resource contention. I check recent deployments and configuration changes, then apply a safe mitigation such as rollback or traffic reduction. After isolating the root cause, I fix it, add a regression test, document the incident, and improve alerting. Explain symptom confirmation, recent changes, metrics, distributed tracing, thread and heap analysis, database plans, downstream latency, connection pools, reproduction, mitigation, root cause, and post-incident prevention. Question 18. How would you implement an LRU cache in Java, and what production concerns would you address? For a simple in-process LRU cache, I can extend linked HashMap with access order enabled and override remove eldest entry to enforce a maximum size. I would synchronize access or use a proven concurrent caching library rather than assume thread safety. Production design also needs expiration, bounded memory, stale data policy, metrics, and a cache miss strategy. If multiple service instances require shared entries, I would consider Redis, while accepting network latency and invalidation complexity. Cover linked HashMap access order, eviction, thread safety, maximum size, expiration, cache misses, stale data, memory limits, distributed caching, and measuring hit rate before adoption. Question 19. How would you explain a difficult technical decision to a non-technical Kyndryl client or stakeholder? I translate the decision into outcomes the stakeholder values: reliability, delivery time, cost, security, or operational risk. I present 2 or 3 viable options, explain trade-offs plainly, and state assumptions and consequences. For example, I might recommend incremental modernization because it reduces outage risk, even if a rewrite appears faster initially. I invite questions, confirm the decision in writing, and define measurable success criteria and review points. Be sure to mention business outcomes, options, risks, cost, timeline, assumptions, visual communication, stakeholder questions, decision records, and adapting technical depth to the audience. Question 20. Describe a Java project where you improved quality, performance, or delivery, and how you measured the result. In one service, database calls caused long response times during peak usage. I profiled the request path, found repeated queries, added targeted indexes, introduced bounded caching for stable reference data, and covered the behavior with integration tests. I worked with operations to establish latency and error dashboards before releasing gradually. P95 latency dropped substantially and database load decreased, while cache invalidation remained a documented trade-off. The experience reinforced measurement before optimization. In your answer, structure the situation, task, action, and result. Explain your individual contribution, technical choices, collaboration, measurable impact, trade-offs, and lessons learned. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.